Good morning friends. In this video we are going to discuss about the fluid property viscosity or the dynamic viscosity or the absolute viscosity. So viscosity is one of the important property of the fluid. In this video we are going to discuss the definition of the viscosity, velocity profile and the Newton law of viscosity, right? So first we discuss about the common definition of the viscosity. So viscosity is defined as the resistant force offered by the fluid when it moves over another rail of the fluid. This is one of the common definition, or sometimes it is called as the resistant force offered by the fluid to its flow, right? So both are common definition of the viscosity. So the viscosity is the property of the fluid which arises due to the cohesion property, and also it arises due to the internal molecular attraction. So one molecule attract the another molecule, so it resists to its flow. So that is called as the viscosity. Okay, so it is arises due to the internal fluid friction and molecular momentum transfer. So these properties will causes the viscosity, right? So next we see about the velocity profile. I am taking a boundary or fixed layer upon a fluid is flowing. So the Y denotes the thickness, fluid thickness, and U denotes the velocity. Okay, so at the wall, due to the maximum shear or the shear stress, the velocity is around 0. It goes on to the boundary to the middle of the fluid. It is a maximum velocity. Okay, here I am taking a small distance dy, or the velocity at the first layer or the y distance, the velocity as u. So the considering distance dy, so here the velocity is u plus du. That means the initial previous layer velocity plus the velocity change due to the change in distance dy. So the velocity at the dy element as u plus du. Okay, right? So the velocity is the velocity profile, or the velocity profile of a fluid is like a parabola, right? So either the laminar flow, so the fluid particles flow in a defined fashion, the velocity profile as parabola. So next we discuss about the unit of the viscosity. The unit of the viscosity is Newton second per meter square, so or Pascal second. So we know that 1 Pascal is equal to the Newton per meter square. So the unit of the viscosity is also defined as Pascal second, or sometimes it should be represented in terms of pies. We are going to appear, or we are going to solve problems, the viscosity is denoted in terms of pies. So 1 pies is equal to the 1 by 10 Newton second per meter square, or 0.1 Newton second per meter square, or 0.1 Pascal second. Okay, right. The next we discuss about the Newton law of viscosity, right? So we know very well about Newton's second law. So Newton's second law, that is force is directly proportional to the acceleration. Okay, here a fluid under rest, when we are applying a shear force or a stress, then the fluid start moving. Okay, so the fluid, once the external force is applied on the fluid, once the fluid start deforming, it continuously deforming, whether the force amount is either small or very big. It does not depends upon the magnitude. It starts deforming, continuously deforming, that is called a fluid. Okay, so here the shear force, so tau, the shear force tau is directly proportional to the change in velocity upon change in distance, that is called velocity gradient. So the shear stress is directly proportional to the velocity gradient or the rate of shear strain. Why I am using rate means the change in velocity with respect to change in distance. So it represents the rate of shear strain. So okay, right? So these are the things we discussed in this video: viscosity or definition of viscosity, unit of viscosity, and Newton law of viscosity. So I hope